solubility. What is the meaning of solubility? Simple. The solubility is expressed as solute per solvent. That is the basic understanding of solubility. I will just read out for yourself. It is the property of a solid, liquid or gaseous chemical substance. It's the property of solid, liquid or gaseous chemical substance called solute to dissolve in a solid, liquid or gaseous solvent. So the ideal concept is solute in solvent is nothing but solubility. So normally if, as per the US pharmacopoeia, if solute is 1 part, then it depends upon how many parts of solvent is required to solubilize that solute, and that govern its solubility. For example, if the solvent part is less than 1, it is known as very soluble. Okay. Then if it is 1 to 10, okay, it is known as freely soluble. Then 10 to 30, it is known as only soluble. Okay, just soluble. Then 30 to 100, this is one time GPAT question, sparingly soluble. Sparingly, okay, sparingly soluble. Then 100 to 1000, slightly soluble. 1000 to 10,000, very slightly soluble, and more than 10,000, it is practically insoluble. Okay, so solubility can be determined by the balance of intermolecular force between solute and the solvent. See, you can refer to our earlier intermolecular force video. There is an interaction between solute and solvent, and that stabilizes, that forces actually govern their solubility. Okay, if there is only 1 part, less than 1 part is required, so that means the solute and solvent is happily interacting with them and to get dissolved in in it. So that's why the intermolecular forces plays very vital, important role in the solubility. Now, after that, what other factors can influence solubility? Number 1, physical, chemical and physicochemical properties of solute. That I will come to very soon when I will discuss with physicochemical properties video. Okay, that I will explain. Then after that, what are the factors? Then temperature, pressure and the pH of the medium. Okay, as I already explained pH and pK relationship. I will be making very soon the percent ionization concept video. Okay, that's also very important for GPAT. And after that, solubility also depends upon the dielectric constant of solvent. Dielectric constant of solvent. Oh, there's no white chalk today. Dielectric constant of solvent. Now, if I just bifurcate dielectric constant, into various regions, like starting from 1.89 to 9.1. Then I will go to from 20, then I will extend to 37.5, then I will extend to 47, 58, 47, 58, and the last one is 79.7. 79.7. Okay, so this is the dielectric constant that I bifurcated. So first one is non-polar lipophilic, non-polar and lipophilic solvents. Okay, now for example 1.89, it is your hexane. Okay, hexane, and 9.1 is your dichloromethane. I'll just write that on the value. 20 is acetone. Okay, 37.5, it is acetonitrile, and the 47 is your DMSO, dimethyl sulfoxide. 58 is your formic acid. Formic acid is not a solvent, but we use them whenever we want to adjust the pH. Okay, it's a buffer. Okay, yes, I will make the video on buffer and percent ionization. Okay, in that I will clear the concept more. So then The next thing is 79.7, that is the water. Okay. So now non-polar lipophilic, okay, in between the range, what are the solvent comes after hexane? The petroleum ether, dioxane, benzene, toluene, diethyl ether, ethyl acetate, and tetrahydrofuran. Okay. Then after that, it is polar lipophilic. Polar but lipophilic. Like example, you have dichloromethane, acetone, these two major solvent. Then after that, you have 20 to 37.5. It is polar lipophilic. Sorry, after polar lipophilic, then it is non-polar hydrophilic. Non-polar, but it is hydrophilic. Okay, so non-polar hydrophilic, you have this your polar hydrophilic. Even this polar, one minute, I should not polar hydrophilic, non-polar hydrophilic, polar. Okay, polar, I will say lipophilic. Okay, 9.120. So where does ethanol come? Ethanol comes is after 20 to 37.5. That means it is hydrophilic. Okay, this is ethanol and methanol. It is hydrophilic and it is having a non-polar nature. So definitely the compound which is having the weak polarity, they also can be dissolved in the methanol and ethanol. Okay, of course methanol is more polar than ethanol because ethanol contains more number of carbon. If you increase the number of carbon, then the hydrophilicity can goes to the lipophilic quadrant. Okay, then after that, from the hydrophilic non-polar, after that you can write the rest of the thing polar hydrophilic. These are the polar hydrophilic solvents. Polar hydrophilic. So that's why you have DMSO. Okay, acetonitrile is also towards the hydrophilic. So this concept is very important for your chromatography because chromatography is all about deals with the mobile phase. Okay. now you come to the like some salt, if it is dissolved in a solvent, okay, sodium plus Cl minus, the solubility. Now if you see, if I write salt as a AXBY dissociated as XAY plus B minus X, Y into B minus X, okay. So then the dissociation rate constant will be A plus Y into X into B minus X root over Y to the power of Y upon AX into BY. Okay, so this is your rate constant. Okay, if you multiply this K into AX into BY, K into AX into BY, that become the solubility product, KSP. So solubility product, if the salt is having high solubility product, their dissociation also high and their solubility also high in the solvent. Now there is a next factor which affect your solubility, is known as common ion effect. Common ion effect. Okay. Now if you put two different type of salt which have a common ion, like chloride, okay, like sodium chloride and silver chloride, okay, you have NaCl and you have AgCl. Now the thing is, the solubility product of NaCl is higher than AgCl, so this dissociation of NaCl is much more. So AgCl, what happened? When sodium chloride dissociates much more, so chloride ion is given by the sodium chloride is much more in the solution. So that chloride ion suppress the AgCl dissociation because it's a common ion effect, and that's why you can find that silver chloride solution, if you add some sodium chloride, it gets precipitated out, PPT, okay, and that's known as salting out. That we will be discussing in our physical pharmacy videos. Now after that, if you decrease the particle size, it increases the surface area, increases the solubility. Now there is a Van 't Hoff equation which relate solubility equilibrium constant